Greetings, students. Today we're going to discuss practice test 1-1. Let's begin solving equations. So again, we're going to use reverse order of operations. So we're going to isolate the x variable by moving the things that are around it from the left to the right side of the equation. So because there's a -4 here, we're going to add 4 to both sides. What that's going to do is it's going to make this a 0. -4 plus 4 or -4 plus 4 is nothing. It's going to change the 12 into a 16. Because 12 plus 4 is 16. Our second operation is division by 2. We are dividing by 2 here because 2 divided by 2 is a 1, which changes this into a simple x, a single x. 1x is the same as x. 2 divided by 2 is 1x. So our answer is in fact 8. 16 divided in half is 8. You can verify your answer very easily by substituting the answer back in for x. So 8 times 2 is 16. And then 16 minus 4 is in fact 12. Question 2. 10x plus 2x is 12x. Now why am I adding these together on this question where I didn't add them together on the previous question? Well, here on the previous question, -4 did not have a x after it. It was not a coefficient of x. So I did not do 2x minus 4 here into a -2 because the -4 does not have an x variable. It's not a coefficient of x, the 4. Whereas here, the 10x and the 2x are both coefficients of x. So they can combine together to make a 12x. Dividing 12 into 60 will yield the answer, which is 5. 5 times 10 is 50. 2 times 5 is 10. 50 plus 10 is in fact 60. So 60 divided by 12 is 5. Next question, solving for y. I'm going to follow a similar set of steps as I did up above here on these questions. Now these again are different variables, so they will not combine together because this is a y. 6 is a coefficient of y and 12 is a coefficient of x, so they will not make an 18 because they are different variables. So I will subtract the 12x from the left to the right side of the equation. Why am I doing this? Because I want to solve for y. I want to isolate the y variable. And again here, 24 and the 12x, they are not similar terms. The 24 is not a coefficient of x, does not have an x with it. So these will stay separate. So I have 6y. I could write this as 24 minus 12x or negative 12x plus 24. I'm going to write it as negative 12x plus 24 because that is slope-intercept form for later on in the year. If you don't remember what that is, let's just put the x before the coefficient. I won't mark it wrong the other way around though here for the first couple weeks. Dividing by 6 will be the finishing step. And again, why am I dividing by 6 and not subtracting 6? Well, because 6 is a coefficient of y. It's 6 times y is equal to negative 12x plus 24. So I have to divide by the 6 to move that 6. I can't subtract that 6 because it's not added to the y. It's multiplied by the y. Anyhow, so 12 divided by 6 is negative 2. 24 divided by 6 is 4. So y is in fact equal to negative 2x plus the 4 here. All right, next question. 104 fluid ounces into cups. So which is larger, fluid ounces or cups? Well, cups is larger. So I've got these 104 fluid ounces. I'm going to divide it by the 8 to make it into cups. So 8 times 1 is 10. And 8 times 3 is 24. Did you notice on question 2 I made a mistake? I do that on purpose often. I put 60 as my answer when we were talking about it being 5 here. So those of you paying attention, that's supposed to be a 5, like we discussed there. 60 divided by 12 is 5. Anyways, next item, question 5. What is the slope to the pair of points? So I got 7 to negative 5 for my x's, negative 4 to negative 6 for my y's. I do this a little differently than some teachers. So again, we're looking at change in y over change in x, or rise to run in terms of what our slope is. So here's my y values. I want to compare my y values. So from -4 to -6, how did I get from -4 to -6? That's my change in y. How did I get from -4 to -6? So if I look at a number line here, here's 0. -4 is left 4. There's -4. How do I get from -4 to -6? Do I move leftwards or rightwards? Well, I move left. And how many do I move left? Well, here's -4. To get to -6, I have to move left 2. So the change in y is left 2. In other words, I had to subtract 2 from -4 to get to -6. And the x variable here, or the x coordinate, how do I get from 7 to -5? And again, if it helps you, you can think about a number line. So 7, here's 0. 7 is which way? Right or left from 0? Well, it's right. 1, 2, 3, 4, 5, 6, 7. There's 7. How do I get to -5 from the 7? Do I go leftwards or rightwards? Well, I go left because -5 is left of 0. So here's -1, 2, 3, 4, 5. How many did I go left to get from 7 to -5? I went left 12. You can count them on the number line, or you can just say, well, 7 and 5 are 12 apart. I'm going left 12. -2 divided by -12. Two negatives, when they divide, they make a positive 1/6. Next item, simplifying radicals. Here I'm asking you to reduce the perfect root. So I'm asking you, does the square root of 4 go into 45? Well, no, because 45 is not even. Not even. So 4 will not go into 45. The next perfect square is a 9. Does the square root of 9 go into the square root of 45? Well, yes, because 9 by 5 is in fact 45. Why is that important that I used a 9 here and not a 5? Because I could just write this 5 times 9 instead of 9 times 5. Well, the 5 doesn't become anything. It stays underneath the radical. The 9 is what reduces. The 9 becomes a 3 because 3 times 3 is 9. So because the 9 is a 3 by 3, it becomes a single number when it's square rooted. Just like the 4 is a 2 by 2, it becomes a single number when it's square rooted as well. Square root of 4, square root of 2 times square root of 2, which is a 2. All right, next item, simplify square root of 64. That is in fact a perfect square all by itself. 64 is already 8 times 8. So as I discussed up here, because 9 was 3 times 3, 64 is 8 times 8. The square root of 64 is 8. Next question, 128. There's a lot of roots that go into 128 that are perfect roots. So we're going to start off with an even root here, which would be probably a 4 for most of you. 4 goes in, it goes in 32 times. The next perfect root that's even is 8. Or not 8. What am I talking about? The next perfect root that goes in would be a 16. 16 also goes in. 64 also goes in. We're going to choose the largest root possible here. Square root of 64 times the square root of 2. 8 root 2. There are other approaches here you can use, as we discussed in class with the factor trees, breaking it down from the factor trees, circling pairs. You take the approach that works for you best. Next item, factor completely. So I prefer to use the X factoring method. Some of the other teachers might have taught you differently. Use the method that works for you. So here's the value of B, always the value of B. Underneath here is the value of A times C. Because A is 1, well, this will be a 9, because 1 times 9 is 9. So again, A was 1, the coefficient of this squared term was 1, in other words. B was 10, coefficient of the linear term was 10, and C was 9. So A times C was 9 in this case. And I'm trying to break down that 9 to make it 10. Well, 9 can break down either with a 3 times 3 or 9 times a 1. 3 plus 3 is 6. 9 plus 1 is 10. So I want to use a 9 and A1. And because A is 1, those are going to be my factors as well. But I will write out the entire process here so that it's easier to remember. So 9 divided by 1 is my first factor, which is A plus 9. Because A was 1, so 9 divided by 1. And 1 divided by 1 is my other factor, which is A plus 1. Neither of those, again, those divide evenly. So neither of those has a reduction factor for the number in the numerator. You can check your work very easily. And I used A here. I should have used K, sorry. K is my variable. K plus 9, K plus 1. I won't take off for the variable, though. If you want to change it all to x's, that's fine with me. I can check my work very easily by doing distribution. K times K is K squared. K times 1 is K plus 9 times K, which is 9K. 10K total. 1K plus 9K. And 9 times 1 is 9. All right, next item, number 10. So here A is 2. B is negative 9. And C is negative 81. So here, my goal number is negative 9. I want to make a negative 9. And A times C is negative 162. The value of A times C goes underneath. So again, I'm trying to figure out the factors of 162 that break down into a negative 9. So to do this, I'm going to start off on the far right here, or somewhere on the paper where I have some space. I already know one of the factors of 162, the given factor, the one I used to make 162, 2 and 81. But that does not make negative 9 when it adds. That makes negative 79. So I'm going to build my way up from 2 until I get the proper factor. So the next factor that could possibly go in is 3, because 3 is 1 bigger than 2. Does 3 go in? Yes. 3 times 50 would be 54. Because 50 times 3 is 150, and then 4 times 3 is 12. Yeah, 3 times 54. So does 54 and 3 make negative 9? No, because they are going to be making negative 51 when they subtract. So the next number bigger than that is a 4. Does 4 go in? Easy way to verify that is to look at 2. 2 went in 81. If 4 goes in, this will have to be divided by 2 again. Well, 81 doesn't divide by 2. It's not even. So no, 4 does not go in. Does 5 go in? Well, it doesn't end in a 5 or a 0, so no, 5 does not go in. Does 6 go in? 6 has to go in if 2 and 3 both went in. So 6 is definitely a factor here. How many? Well, if I look at the 3, I can divide this number by 2 to get how many times 6 went in. 27. Does that make negative 9? No. 6 minus 27 is negative 21. Does 7 go in? No. 7 times 2 is 14. 22 doesn't divide by 7. Does 8 go in? 4 didn't go in, so 8 can't go in. Does 9 go in? Well, if 9 goes in, the 54 would have to be divisible by 3. So does 54 divide by 3 evenly? Yes, 18 times. So this is the process you need to go through when you're doing this type of work, or a process similar to this. Figuring out the proper factor set that you're going to use to make the given A times C. So 9 and negative 18. Now again, because A was not 1, I'm going to divide both of these by the 2. So 9 divided by 2, so that is my first factor. That doesn't reduce, so that's 2A plus 9. And then the other factor here is negative 18 divided by 2, which does reduce. It makes negative 9 over 1. So my other factor is A minus 9, not 2A minus 18, because again, that reduced. I can verify my work very easily again. There's 2A squared, 2A times A. Negative 18A plus 9A is negative 9A. And then negative 9 times positive 9 is negative 81. This is the longest question on the test. I'd recommend you save it for the last question, unless you intend to have a lot of time. unless you think you're going to have a lot of extra time. Sorry, the lights just turned off. Let's turn on the Elmo light here. Question number 11. Distribution. Negative 9a times negative 1, that is negative 9a. And then negative 9a times negative 6a, or minus 6a, is positive 54a squared. A times a is a squared. Negative 9 times minus 6 is positive 54. Similar thing here on number 12. Negative 2 times negative 1 is positive 2. And negative 2 times plus 7 is negative 14. Some of your teachers might care that it's in descending order. I didn't state in the question that it had to be descending order, so some of you might have to reword this as 54a squared minus 9a and negative 14r plus 2, if your teacher says so. Anyways, that's the first page. I do intend to make each of these questions worth 4 points on the first page, so that will be worth right there. That's 48 points. That's roughly half the points on the tests. Give me a second. I'll set up page 2. All right, I'm back. All right, question 13. It's kind of a miswording here, misprinting here. It says x was 12. That's not what I'm asking. I'm asking you to substitute the x back in. So ignore what this says here, x equals 12. X is equal to 12 here on this question. All right, guys? And I'm going to fix that for the test, and I'll probably fix it for the review. I'm just going through the review beforehand here. So the 12 replaces the x. That becomes 4 times 12 minus 8. And then 48 minus 8 is my answer, which is 40. Again, I'm asking you to substitute the x back in. I'm not asking for what x was equal to here. All right, question 14. 12 plus 6 is 18. And then 6 minus, I'm going to do the 3 squared first before I subtract. So 6 minus 9, not 6 minus 3 then squared. 6 minus 9. So 18 divided by negative 3 is negative 6. So the order of operations. We start with parentheses, then we do exponents, then we do multiply, then we divide, then we do add, and then we do subtract. That's what we do when we have numerical operations to do. And we reverse the order when we're solving equations. All right, so question 15. I'm going to start off by adding the 8 to the 4, similar to how I do the questions on the front. How am I going to clear the x from the denominator here? So this is 60 divided by x, not x divided by 60. How am I going to clear the 60 from the denominator? I'm going to multiply by it. Why am I multiplying by x and not by the 60? Because the x is the part that's dividing, not the 60. So I'm going to multiply both sides by x. That's going to make this into a 60 equals 12x. And I can divide by 12 to finish the question. Again, what we're doing here on this question is clearing the x from the denominator, moving it up into the numerator, or from the denominator to where it's not in the denominator anymore. All right, question 16. I'm going to multiply both sides, everything by 8 here. This is again clearing the denominator. So why didn't I just multiply everything here by x? I could have. If I multiply everything here by x, I would have gotten 60, negative 8x, positive 4x. And then if I add 8x to 4x, I would have got 12x. So I'm doing the same thing on both of these questions. Even though they're written slightly differently, I'm doing the same type of thing. I'm clearing the denominator. So here I'm clearing the 8 out by multiplying everything by 8. Everything meaning both sides of the equation. So the x and 10 don't multiply separately by the 8 because they already have the 8 as the denominator. So they become 10 plus x. They don't change. But the 8 does multiply by the 12 here, which will make a 96. Subtracting 10 from 96 equals an 86, my finished answer. Next item, describe the pattern. I like to work from small to large when I have single-digit numbers in any way in the pattern. So I'm looking at the 6, the 18, the 54, and the 162. And I'm asking myself first, is there an additive or subtracting pattern? So to get from 6 to 18, I'd have to add 12. Am I adding 12 again to get to 54? No, because 12 plus 18 is 30. So now I'm going to look at multiplying. To get from 6 to 18, I had to multiply by 3. Am I multiplying by 3 to get to 54? Well, 3 times 18. 3 times 10 is 30. 3 times 8 is 24. 30 plus 24, 54. I'm multiplying by 3 again to get to 162. 4 times 3 is 12. And then 50 times 3 is 150. 150 plus 12, 160. Yes. So now I did work this backwards. I said we're multiplying by 3 to get from here to here. So what are we actually doing to get from the left to the right? We are dividing by 3. And what is 6 divided by 3? That is the next term. It is 2. All right, next item here. These are all fractional. So I'm looking at this one. I'm thinking, oh man, it's all fractions. But then what you should notice is look at the numerator and the denominator separately. They have a little pattern going on separately, top and bottom. What are we doing in the numerator here? We are subtracting by 2. And what about the denominator? We are adding 3. So we're taking minus 2 from the numerator, and we're adding 3 to the denominator. So if I take 2 from 13, I get 11. And if I add 3 to 12, I get 15. Sometimes these patterns are not necessarily as straightforward as you would like them to be. Sometimes you're going to have to look at them for a while. Take your time, look at them, think about them, as we discussed in class previously. Next thing, the sum of two prime numbers is even. I said give a counterexample. So this is a false statement. I'm not going to ask a counterexample if it's not a false statement. This is a false statement. So there are two prime numbers that when they, this is multiply or add. What does sum mean? It means to add. There are two prime numbers when they add that are not even. At least two prime numbers when they add that are not even. So let's think about the prime numbers. So the prime numbers are numbers other than 1 that only divide by themselves and 1. So the first prime number would be at 2. Prime numbers. The next prime number after that would be a 3. 4 would not be prime because 4 is divisible by 2. But 5 is prime because it doesn't divide by 2 or 3. 6 divides by both 2 and 3, so it is not prime, it's a composite. 7 is also prime, so here's some prime numbers. I've done 4 prime numbers. Let's see what these add up to make. Well, 7 plus 5 is 12. Should I use that as my counterexample? No. Why not? Because 7 plus 5 is 12, and that is already even. I want a counterexample. I said, prove it false. What about 5 plus 3? 5 plus 3 is 8. That's also even. Is that a counterexample? Well, no, because that is even. What about 3 plus 2? 3 plus 2 is 5. That proves the statement false because I said that the sum is even when you add two prime numbers together, but the sum does not have to be even if we use 2 as one of the prime numbers. All right, next thing, plotting on a number line. Plot them in order, please. Starting with D. D, -4. E's at -2. F's at 0. And G is at 6. My G's look kind of silly, sorry. Always have. Next thing, intersection of plane BKM and FEK. So BKM is the top of this box. BKM. There's BKM, the top of this box. And FEK is the left side of this box. And I said box, I mean, it's not really a normal box because it's got this trapezoid front and back, but it's got 4 sides, so it's kind of like a box. So what do they share in common? BKM, which is the top of the box, and FEK, which is the left of the line. Well, they share the segment here, or the line, I should say, BK. What about plane MKE and ray HE? MKE is the front, and ray HE is this little array that's pointing left. So should I reword this as EH? It said to do alphabetically here. Should I word this as EH? Does E point towards H? No. H points towards E on this ray. I should keep the wording the same. Ray HE. H points towards E. What about ray EJ and ray JE? EJ points to the right from E, and JE points to the left from J. What do they share? They share the segment from E to J here in common. The segment. E to J. Name a point not collinear with E and H. So which one is not collinear? Well, E and H are here on the front of the box. G is on the back of the box. F is on the back of the box on the back of the box, bottom of the box with E and H. K is on the front of the box. M is on the front of the box with E and H. So not collinear would be B or C. I would put C as my best answer here. But B is also appropriate in terms of not collinear with both those points. Because you can't draw a point from E to H going through B or C. Or in fact, you can't actually go to M, K, F, or G as well. None of these points are collinear except for J. I was doing coplanar as well, but I was doing coplanar when I was thinking about it. But none of these points are collinear except for J on this figure. A line segment coplanar with BF. So BF is on which sides of the box? Well, it's on the back of the box, so I could put BC or FG or CG. It's also on the left of the box, BK, BF, EF, or EK. I could put any of those. I'll put B to C. Coplanar, a line segment. All right, a point coplanar with F and B. F and B go with, well, I already said they go with C. I could have put G or K or E here. All right, are the figures coplanar? B, K, H, and G. B, K, H, and G. Now, they don't have a plane drawn through them, but you could draw a plane through them, as we discussed previously from the book. So this answer is in fact yes, because you could draw the plane through these 4 points. It could be drawn connecting these 4 points. What about EJ and MH? EJ and MH, yes. EJ is this ray on the front. MH is this segment on the front as well. Yes, they're coplanar. Anyways, I hope this helps. If you have questions, please come in after school. I'll be here. Good luck.